Okay, so now we will see time period of various cases. Okay, so I will be just telling the case and formula, only the formula and the case. So number one, a ball oscillating in a bowl. Okay, so a hemispherical bowl is there, so we can say hemisphere. Okay, so from here a ball is there, so this will be going to the other side, this will be moving simple harmonic motion. So this ball will have a radius small r and this will have a radius capital R. So this time period is going to be usually 2 pi into root of L by G thane. Okay, so inga vandu 2 pi into root of R minus R by G. Okay, 2 pi into the radius of the hemisphere minus radius of the ball divided by G. How this comes? If you have that question, you should go through the derivation. Okay, you should go through the derivation. Take any reference book if you are interested, or otherwise somehow try to find out the derivation and try if you are able to understand. All right, clear? Very clearly I am saying this is radius of the sphere, radius of the ball. Number two, okay, this is Earth. This is its diameter. This is its diameter. So suppose if you keep a ball here, it will attract towards its center. It will come like this. It will not stop. It will go due to inertia. It will go to the other side and it will be doing simple harmonic motion here. So here the time period is going to be 2 pi into root of R by G. Okay. So this is, we will be getting 84.6 minutes. 84.6 minutes it will take. Okay, clear? Now third case is same Earth. The difference is not through diameter, but along its chord. Same formula. Will come. So in a YouTube, water will be there up to a height. Now if we apply some pressure, what will happen? It will go to this side, and if we leave like that, start doing SHM. Okay, if we neglect friction, viscosity and all. So suppose if the vertical height of this is, you can tell what will be the time period 2 pi into root of h by g, then if the length of the U-tube, is equal to L, okay, length of the U-tube is equal to L, then we can say we can neglect this length, or L is equal to what, 2h, or we can write h is equal to L by 2. So then this time period will take the form 2 pi into root of L by 2g also. Floating body. If a body is floating, okay, if a body is floating, and if the height of the body is h, okay, so here again 2 pi into root of h by g, same formula, okay, but here instead of height, if they give in the form of area of cross section and this density of the body, if this is body, density of the body, if they give like that, this formula I am giving just for remembering purpose, because most of the cases are same. Okay, so in that case what we will have to do is T is equal to 2 pi into root. So in this case mass divided by mass of the body by body into g. So this is area of cross section, area of the cross section. So here but there is a trouble here. This is going to be area of cross section into density of the body into g itself, mass itself. So okay, so here mass of the, okay, leave it, I will give you, I have some doubt in this formula. Okay, just remember this one, the another formula is there that I will give you later. Okay, so take that one, and one more formula is there that I will give you later. Okay, now conical pendulum. Okay, this need not be cylinder, this can be any body. Okay, need not be cylinder, this can be any body. Okay, conical pendulum. So this conical pendulum is, so this will be moving a round manner. This will be making a circular motion, simple harmonic motion. So that is what is conical pendulum. So suppose if this is theta and if this is L, then T is equal to 2 pi into root of L cos theta divided by G. Okay, actually we have taken till now. Now this time we are going to take the vertical height, so that will become L cos theta. Okay, so this will be moving like this, conical pendulum.
It is of the water column or body.
Just I have a doubt there. Okay, keep it like that. I will correct it and tell you the full details. That floating body, okay, that keep it like that. I will verify once again. I will give you full details. Okay, that floating body alone. This is important also because this is given in NCERT backside exercise. That case is given in NCERT backside exercise. So we will be getting some cases like this in backside exercise also. They can ask that also. Right, now question is now 7th case. So suppose a wire, okay, a length L, a wire of length L, if we instead of spring, simple wire, there will be a small deformation, right? So if we consider that, a small SHM will be happening in this also. Okay, so time period of that one. So T is equal to 2 pi into root of young the body. Okay, this is mass into length divided by Young's modulus into area of cross section of the wire. Okay, next one, suppose if there is magnetic field like this, if you are suspending a bar magnet, okay, suspending a bar magnet, north pole, south pole, then there will be, okay, suspending a bar magnet, suppose if we give a disturbance, it will do what? Because of torque, it will do a simple harmonic motion. So time period is equal to 2 pi into root of I divided by MB. Okay, I is the moment of inertia of the magnet, M is the magnetic moment, B is the magnetic field intensity. Okay, so these are some of the general cases which we can see. Lot are there, many are there, but whichever is easy, whichever is possible to study, you can do that. And simple cases are there. If we keep a charge here, we keep another charge plus q, here if we keep a minus q, this will also do what? Simple harmonic motion. So you can do all those works and you can add that to these points. Wherever you find cases and if you are able to understand, please add all those cases into additional points to these pages. Okay, then see 4 charges are there, 1 2 3 4, in between another charge is there, minus q. So these 4 charges also can pull this. So all the horizontal components will be cancelled off, because if this is the force towards one charge, this is horizontal component, this is vertical component, then this charge will cancel that horizontal component. So likewise only vertical component will be there. So using that we will be able to find the restoring force and do. Okay, so study till this carefully. And whenever we study other chapters, wherever you get an oscillation, add to this one. Okay, right, clear? Now we will see the type of oscillations. type of oscillations. So number one, just till now whatever we were studying, free oscillations, free means it will be just like this. Okay, we can say amplitude is constant, whatever we were studying till now. Amplitude is constant, it will not be weird out. Okay. Okay, so only one influence is there, it is under influence of restoring force. Under the influence of restoring force. Second, damped oscillation. Damped oscillation. So here I will give you points. So here amplitude decreases exponentially. Okay, amplitude decreases exponentially with the passage of time. Okay, amplitude decreases exponentially with time. Okay. So how this amplitude is decreasing? That is not the reason for this damping is nothing but non-conservative forces. Example, friction, viscous force. Okay, all these things will now only till now only restoring force was there. In the case of damping, retarding force will come. Retarding force will come. Retarding force. So generally this retarding force F is equal to minus BV, minus BV. This is force, this is velocity. This B is called a damping constant, damping coefficient. B is damping coefficient. Damping coefficient. So for example, now we write restoring, see, now suppose if we do oscillation inside this, okay, definitely if there is viscosity in this will stop this movement with the passage of time. After some time this will be stopped. So restoring force is what? Minus kx. So can I mark this as minus kx? Okay, this retarding force also will be in which direction? That also will be negative. if we consider the movement in this direction, then the retarding force will be in the upward direction. So I can write minus kx is the restoring force. Along with that, I can write what? Minus bv also. Minus bv also. Okay. So this is the net force, we can say ma. Correct or what? Okay. Okay, just for understanding purpose, we are not putting mg and all here. We are not putting entire forces. Just simply the force which is acting along with the restoring force now. That alone we are considering here. Okay, so minus kx minus bv is the factor which is going to stop this. Okay, not minus kx, minus bv is the factor which is going to create damping. Clear or what? Minus kx minus bv is equal to ma. Any doubt in this? Clear? Now see, minus kx, can I write b is equal to dx by dt, and this is equal to m into d square x by dt square. So m into d square x by dt square plus b into dx by dt plus kx is equal to 0. This is the differential equation for damped oscillation. Differential equation for damped oscillation. Now if I solve this equation, this is a quadratic equation in differential form, right? If mathematically if I solve this, I will be displacement. Inga enna irukku? D square x by dt square, inga dx by dt, inga x. Actually x is the variable. Okay, so if I solve this, I will be getting displacement x is equal to a e raised to minus b by 2m into t. Okay, cos omega dash t plus phi. So this is the equation of displacement in damped oscillation. Okay, a is the initial amplitude. A is the initial amplitude. This is not constant, Leah. Previously we wrote a cos omega t. Previously we wrote a cos omega t. What shape we got? When we wrote a cos omega t, when we got is equal to a cos omega t, the shape of the wave was this. Now cos omega t is there. Cos omega t is there. E raised to minus xt or minus t will give what shape actually? This is the shape of e raised to minus x. If this is x, then e raised to minus x shape is that one. Clear? Adu theriyumilla? Okay, now we will put everything together. If we put everything together, then this is the exponential shape. This is the exponential shape. Now if I take like this, I can mark like this. Cosine or sine interchangeably, no worries. Okay, when I am doing a sine, a cos, that is not an issue. Sine or cos will come, but it is damped like this. So that is why initial amplitude a is here, minus a is here, but this is decreasing. E raised to minus b by 2m is decreasing like this. Okay, this B is already, I told, this is the damping coefficient. M is the mass. Okay children, now here we have put an omega dash. What is this omega dash? Omega dash is the damping frequency. Damped oscillations frequency is what is omega dash. So omega dash will be omega was what? Root k by m. Omega was root k by m. Now this one is root a by m will be there, but along with that minus b by 2m the whole square. Okay, or otherwise we can write this also, root omega square minus b by 2m the whole square. So this is what is damped oscillations frequency. This omega, this is natural frequency. Natural frequency when no retarding force is there. There was no retarding force. Till now whatever we have learned is this omega. Okay, so damping frequency is this one. See children, so from here this term is the amplitude. Damping oscillations amplitude is this one. So I can say A dash is equal to A e raised to minus b by 2m into t. So b by 2m is coming here. Okay, b by 2m is coming here. E raised to minus b by 2m. So the figure which I have shown is, this is slowly decreasing. Okay, so if the damping is very strong, there itself the oscillation will stop. Okay, so that is called over damping, critical damping, under damping. These things are there. I will give that also. Shall I erase this? Okay, so b by 2m, this can be less than omega. B by 2m can be equal to omega, or otherwise b by 2m will be greater than omega. Okay, so when it is less than omega, I can say under damped. Under damped. Just if it is equal to omega, we can say critically damped, and if it is greater than omega, we can say over damped. Okay, clear? Done. So suppose if we take energy was constant in natural thing. I mean when there is no damping, total energy was what? Constant. But here conservation of energy will be there obviously, but that energy will be taken by whom? This non-conservative forces are there. Friction is there, viscosity is there. So mechanical energy, what will happen to mechanical energy? This total energy will be damped. That also will be damped like this. Correct? So if this is energy, the total energy was what? Half k a square. Half k a square. So but with time this will start decreasing exponentially. I could say E is equal to half k a square amplitude. Now what is the amplitude here? E raised to minus b by 2m into t. So let us put a square there over. Okay, clear? Okay, so till damping only in NCERT, last page you can see damping. Okay, so I believe I have given some extra details of this damping, so that at least if we learn till this, then only we will be able to remember. Paadi venda madri padichinu vechinga, we won't be able to remember the things. So half cooked irukku kudadu. So once if we start, or at least a minimum level of the solli irukonu. So since it is coming in different types of oscillation, that forced oscillation also I am going to give the details, but give priority here. This one no compromise, everything just study this. That also I will give some details, okay, just for understanding. Okay, so this is nothing but due to damping what will happen, this oscillations will be weird out. Illamaidu. So they will give energy for maintaining the oscillation. So this we can say that maintained by external energy. Maintained by external energy. Okay. This oscillate with driven frequency omega d. So this oscillates with the driven frequency omega d. So external force F external, okay, this is F naught cos driven frequency cos omega d into t. So this is the condition of force. So in the previous case, in the damped oscillation, we have written minus kx minus bv. This is equal to ma. This is what I have written. But here I am going to add one external force. So this is going to be F naught cos omega d into t. So equal to ma means ma of t, this is going to be variable. Okay, so m into d square x by dt square plus b into d square x by dt plus kx is equal to f naught cos omega d into t. So when you solve this, we will be getting the displacement a into a dash cos omega d into t plus phi. That is the equation of displacement. ಇಲ್ಲ ಇದು ಡಿ Okay, what is that A? Amplitude of forced oscillation. So amplitude of forced oscillation is f naught divided by root of m square omega square minus omega d the whole square plus omega d whole square b square. This is omega d square. Okay, and square is also there. Okay, so this is the amplitude.